Alright, you guys, for the second part of this packet, all the numerators are going to be smaller than the denominator. Let me say it the way I typed it. The denominator, the degree of the denominator is larger than the numerator. So the degree of the bottom, so like x over x squared. Alright? The degree of the bottom is bigger than the top. I've already gone ahead and factored it for you because that's the first step you guys are supposed to do. And what I want you to see is this thing cancels, which gives you 1 over this. Now, if I asked you guys to divide the bottom into the top, so remember, the first thing I ask you to do is factor it. Second thing I ask you to do is then simplify it. Then the third thing was the q of x plus the r of x over d of x. Okay? So, we're at the simplified stage, 1 over 2x minus 3. I'm asking you, can you divide the bottom into the top? No, it doesn't go in. It's the bottom is bigger than the top. If the bottom is bigger than the top, I can't divide it in there. It's like 1 over 12. You can't divide the bottom into the top. It doesn't fit. Okay, so it goes in no times, and this is what you're left with. Now, do you really have to write the 0? Well, remember guys, I'm telling you, does this have a variable with it? Nope, it doesn't have a variable with it. So if you were to graph y is equal to 0, what are you going to see? You're going to see a horizontal line at 0. And that's what you've got here. You have a horizontal asymptote. Whoops, sorry guys, not very horizontal. A horizontal asymptote. Okay. This is still going to create your vertical asymptote. What's going to make this equal to 0? Well, divide by 2, subtract the 3, x equals negative 3. Oops, I copied it wrong. Oops. Man, oh man, oh man. So that's x minus 3, and that's a minus 3, so that when I add that over there, I get a plus 3. Okay, here's your vertical asymptote. Running right down there at 3. 1, 2, 3. Okay? When you look at your table, this is the hole. That's your removable discontinuity. This is your vertical asymptote. Setting this thing equal to 0 gives you x equals negative 3. That created the hole in the graph. So at 1, 2, 3, there's actually a hole right there. You'll never see it on the graph. You'll have to algebraically find the hole. Okay? How do you find the hole? Well, we know the x value is negative 3. Now how do you find the y value? You put it back into the simplified form. Take the negative 3 and fill it in, and you get 1 over 2 times negative 6, or negative 1/12. That's the y value of the hole. Okay? Alright, I've already factored it for you, because remember the first step was factor. So I've done that. There it is. Does anything cancel? No. So the simplified form, there isn't one. Can you divide the bottom into the top? No. This is the q of x plus the r of x over d of x. Why can't you divide the bottom into the top? Because the bottom is physically bigger than the top. You can't do it. 3 7s. I can't divide the bottom into the top. Okay? So it goes in no times plus basically just the original question. All I'm really doing is putting the 0 in the front of it to help you guys see this is your q of x. So your horizontal asymptote is at 0, and there it is. Your horizontal asymptote is at 0. Sorry, I had difficulty drawing that line. This is going to create your asymptotes that are vertical. You're going to have 2 of them. One of them is at 2, one of them is at negative 1. So 2 units over, there's your vertical asymptote. 1 unit back, there's your other vertical asymptote. Okay? So once again, it would find your asymptotes for you. All right, so let's do 2 quick examples. First thing is factor it. X plus 4 over x plus 4. Sorry, my 4 just closed. Let's see if we can't get rid of that. Looks like a 9. Okay. This is going to cancel out, so yes, there is a simplified form. Can the bottom divide into the top? No. 0 plus 1 over x minus 2. This canceled out. Set it equal to 0. It created a hole. It created a removable discontinuity. Negative 4 is the x value. How do you find the y value? Fill it back into the simplified form, and you get 1 over negative 4 minus 2 is 1 over negative 6. I'm so sorry, guys. That closes. Okay. Vertical asymptote. Vertical asymptote, let's look at the q of x plus r of x over d of x. You're going to look at your d of x, your divisor, set it equal to 0, and it gives you x equals 2. Looking at your q of x, you've got y is equal to 0. That's going to be a horizontal line. So you don't have an oblique asymptote. X-intercept, you could set the original problem, be it this form or this one, set it equal to 0. Cross multiply. 0 equals x plus 4. Now, you need to be careful here. When you solve this, you get x equals negative 4. But look at the x value of your whole. You don't have an x-intercept. That's once again why I'm saying I think it's valuable to use your simplified form, not your original, because when you cross multiply, you get 0 equals 1. How often is that true? Never. So there is not an there isn't an x-intercept. Okay? Y-intercept. Let x be 0. Negative a half. Domain. Okay, you could graph it and look at it, but I'm trying to just decipher the holes here for you. You have a vertical asymptote at 2, so x cannot be 2. You have a hole where x is negative 4, so x can't be negative 4. What you guys need to get out of this is just look at your denominator. D of x is going to create either a hole or a vertical asymptote. But either way, it can't be those. Okay? We don't have an oblique asymptote. We can talk about range. This is a hole, and that's a y value it can't be. Y cannot be negative 1/6 because it's a hole in the graph. This is also an asymptote. Y can't be 0. So it can't be those two values. So I looked at the removable discontinuity in both of these. I looked at the vertical asymptote here and a horizontal asymptote here. Okay. This one, factor it, x plus 4. Let's see, what do I got? So it looks like minus 3 plus 2 or plus 2 minus 3. Sorry, I forgot the x. Nothing cancels. So there isn't going to be a simplified form. I'm supposed to do the division. I can't because the bottom is bigger than the top. So it really is just the original question. Doesn't matter if you write it factored or the original multiplied out. Because nothing canceled, you don't have a hole. Because nothing cancels, you're going to have 2 vertical asymptotes. I'm setting the d of x equal to 0. Oh, I lost the mouse. Where did it go? There it is. X equals negative 2. So you have 2 vertical asymptotes. Whoops, I don't know what that symbol was about. And negative 2. You have a horizontal asymptote at 0. Same reasons I discussed over there. You don't have any vertical or oblique asymptotes. X-intercepts, nothing canceled, so I'm welcome to set this equal to 0. Cross multiply 0 equals x plus 4, or x plus 4 equals 0. So negative 4 is your x-intercept. Y-intercept, let x be 0, and you have negative 2/3. Domain, it's what made the denominator 0. So x cannot be positive 3 and negative 2. And notice in this case they're both vertical asymptotes, but in this case it was a whole, the x value, and the x value of your vertical asymptote. Range, the only thing, y cannot be 0, because you got a horizontal or oblique asymptote. I had it right the first time. The horizontal asymptote. Okay? Alright, that ends day 2.